Now let's talk about the extruder. I think the extruder mounting bracket was designed by the work experience kid. Several errors in it, design faults. First of all, you got two mounting holes, but one is accessible quite easily, the other one is underneath the motor. So that means that if you want to move it up, you have to pull the motor out just to loosen it off, move it, tighten it, put the motor back in, check it. Oh, not enough, too much. Pull the motor out again, put it back in, check it, tighten it. That's one reason why these crack. The other reason is the silly design. There's a lip here, which this is designed to fit over. But to get the motor in the smaller hole, you have to force this bracket open fairly wide, 20mm or so here. So that's why a lot of these break along here, because you open them up and they snap off. They put a massive lug on there, which is okay, but it doesn't need that much force. What they should have done, had a split design and put this lug, matching lug on there. So you have two halves. Then all you have to do is undo that, take off the bracket, top half, the motor will easily come out, and then you can tighten it and loosen it up. But that's that ridiculous design. A much simpler one, again, once you get your printer going, you can make modifications and throw these out and don't waste your time. A simpler design is to have a section like that and flat. So it's flat, up, across, down, flat. So basically here, with two arms coming out, that's where your screws mount. So it would sit on flat, two screws would mount on there, and then that's how you can move it up. You don't even need this part. If you wanted to, you could put a bit of sponge here on there, that if you didn't want it to stick straight to the aluminium frame up the top or whatever. So that's that silly design. Now the next modification is that all those printer nozzles that you jam and you can't get the stuff out and you got them sitting around or thrown away, don't throw them away. Just get a drill out and drill a hole in it. And this is for 1.75mm filament. Just drill it out 1.8, let's say. It will reduce the V on the tip of the nozzle, so deburr it with a larger drill just by hand to take the sharp edges out. Then put it inside the extruder. The reason for that is when you're doing ABS and PLA, that's okay, and you have a jam, the extruder is still working, because this is another flaw that 3D printers have, and I plan to modify it so as it works better. They really need a wheel that is fed off the filament, and as the filament moves, the wheel rotates before it goes to the feed mechanism. So that way, when you get a jam and the software is saying feed more in, and your mechanism is spinning around, churning big hunks off the filament, it still thinks it's printing. The stupid computer isn't that smart. It says, oh yeah, I'm feeding it 5 mil a minute, yeah, no worries. And you get a blocked head, stripped filament. So make up a feed roller, it can be a pinch roller, and put an encoder on it. Now an encoder can just be a couple of veins cut in there and get a infrared sensor, slit type, or just put a couple of magnets on it and a Hall effect sensor. So when it rotates, it's sending a signal, bip, bip, bip. The Arduino says, yes, I'll check for a signal every 5 seconds, let's say. And if there's a signal, bip, yep, doesn't matter how many there is. It can be 1 or 1,000, but just say, is there a signal in the last 5 seconds? Yes, okay, it's feeding. Is there a signal in the last 5 seconds? No. Hey, something's wrong. Let's stop the printer. Let's flash a light, blast a horn, whatever. Then it hasn't stripped everything away. you're notified of a jam, you can quickly come and do it rather than waiting to be told about it. So that's on the in feed. But if it is jammed and you have some softer material you're printing, because of the gap between there and there, it will start to fold on itself. So it'll be feeding and hitting a roadblock and binding up. So what this does, it's a guide. So it actually allows pretty close to the wheel and it will guide it through, no problem. So you won't get any kinks, any bends. So these photos will show you how to pull it apart and put it in. And you just screw the nozzle up tight, it's M6 in there, like such. And then you just screw the quick connect on it and lock it. Nozzle won't come loose, it's got the lock nut that end, that won't come loose. So sweet. But I'm just deciding whether to mount it up the top like it's recommended, but some people say put it on the side lower and you can reduce the amount of tubing you need, which means there's more force to push it through. So that's a decision I'll come to later. You may notice on the stepper motor I've now twisted the cabling. Just Google twisted pair and you'll find out why. When you're using stepper motors, that type of thing, if you use a twisted cable, less outside influences can affect the signals. If you pull your PC apart and you'll see the LEDs and all that, they're all twisted pair to stop crosstalk, that type of thing. And it's quite easy to do. Just twist it, then get something like a peg and allow it to stretch out straight. And if you're in summer and it's hot day, cold night, hot day, cold night, it will soon get that memory and it doesn't unravel. If you just try to twist it, let it go, it will then unravel. So keep it taut 1 or 2 days and you'll have no problem. Take the end off, put the sticky tape on like on the other video, and then just feed it through. I've ordered red, yellow and green sleeving, so when that comes I'll put it on. If not, I'll just put an assembly until it does come. I'm not going to cut the leads off short at the moment because I'll wait and see how everything goes for room. So also another good reason for twisting it, you can have it in a smaller bundle inside your electronics, and that's what we'll move on to next. I will wrap up all the wiring to the effector, so you know how to do that from the previous videos. Next time I'll talk to you, it'll be about the electronics.